Imagine a hotel so vast that no one has ever seen its end. You walk down the corridor, counting room after room, 1, 2, 3, 4, and it just keeps going. You start to wonder, how many rooms are there? You stop counting. Maybe 1,000? 10,000? 1,000,000? You quickly realize that these numbers don't make sense anymore because the hotel is infinite. And here's the unsettling part. The hotel is completely full. Every single room is occupied, and yet, somehow, the manager tells you, "Come in, we can still find you a room." Not just you, but an infinite bus of new guests can also check in, and after them, another infinite bus, and another. Your mind starts spinning because your intuition screams that this is impossible, but mathematically, it works. This is Hilbert's Infinite Hotel, a thought experiment created by David Hilbert to show the mind-bending nature of infinity. David Hilbert was born on January 23, 1862, in Königsberg, a city famous for philosophy and mathematics. It was the birthplace of Immanuel Kant and the location of Euler's Seven Bridges puzzle. Hilbert grew up in a family that valued education and curiosity. His father was a judge, his mother artistic and intelligent, encouraging young David to ask questions and explore ideas. He wasn't a child prodigy in the usual sense. He didn't solve complex integrals at age 3. He was a normal kid, curious, methodical, and confident. People said he had an aura that made him believe any intellectual problem could be solved if only you thought clearly enough. In 1880, at age 18, Hilbert entered the University of Königsberg. Mathematics was in a state of upheaval. Old assumptions were breaking down. Logic was being reconstructed. Infinity, once a vague idea, was becoming a serious problem. Hilbert stepped into this shifting world with calm confidence, believing everything could be understood through clarity and reason. He completed his doctorate in 1885 and quickly rose through the ranks. By the end of 1895, he was a full professor at the University of Göttingen, the mathematical powerhouse of Europe. Göttingen was more than a university. It was a hub where Nobel-level physicists and mathematicians converged. Hilbert became one of its pillars. By the early 1900s, the name Hilbert was synonymous with mathematics in Europe. He was known for his friendliness, clarity, and unshakable belief in human intellect. He loved discussions and could talk for hours on a problem. His students adored him. He famously said, "We must know. We will know." That was his life motto. No nonsense, no surrender. His laugh could fill an entire hallway, and when he focused, the world disappeared around him. Colleagues said his mind worked like a machine once he began thinking.
Hilbert is also famous for his 23 unsolved problems, presented in 1900 at the International Congress of Mathematicians in Paris. These weren't mere puzzles, they were a roadmap for the next century of mathematics, shaping entire fields and guiding research for decades. Some remain unsolved today. Hilbert believed mathematics should be unified, clear, and rigorous, a single structure built on solid foundations. This dream eventually collided with Kurt Gödel, who proved that complete consistency in mathematics is impossible. But that story comes later. Hilbert's fascination with infinity was shaped by Georg Cantor's groundbreaking work. Cantor proposed that infinity comes in sizes, introducing cardinal numbers like Aleph 0. He showed that some infinities are larger than others. Many mathematicians resisted. They felt Cantor's ideas were too abstract, too imaginative, and potentially destructive. Hilbert, however, defended him fiercely, saying, "No one shall drive us from the paradise that Cantor has created." Infinity, Hilbert believed, was not frightening. It simply needed structure, logic, and understanding. This philosophy gave birth to the Infinite Hotel. Hilbert imagined a hotel with infinitely many rooms, numbered 1, 2, 3, 4. The hotel was fully occupied, yet he posed the question, what happens if a new guest arrives? In a finite hotel, the answer is obvious, no vacancy. But Hilbert's manager simply asks each guest to move from room N to room N plus 1. Room 1 becomes free. The new guest checks in. This simple trick demonstrates that infinite sets behave differently than finite ones. Infinity is counterintuitive, yet precise. Now imagine the next scenario. An infinite bus arrives. Infinitely many passengers want rooms. The manager asks each current guest to move from room N to room 2N. All even-numbered rooms are filled. All odd-numbered rooms are empty. The infinite bus passengers fill the empty odd-numbered rooms. The hotel remains full, yet every new guest is accommodated. Infinity is not fragile. You can add infinity to infinity, and in terms of cardinality, nothing changes. This example is where many students feel their brains short-circuit, which is exactly Hilbert's intention.
We can get even more playful. Suppose multiple infinite buses arrive. Suppose guests are moved to prime-numbered rooms, leaving composites empty. Suppose the hotel extends into negative integers or rational numbers. You can even imagine trying to check in uncountably infinite guests, like the real numbers, which breaks the hotel. Each variation teaches us something profound about the sizes and rules of infinity. Let's pause to explore why this matters. Infinity is not a number. It is a concept with its own rules. Human intuition, evolved to handle survival in the finite world, fails here. What seems impossible becomes possible. What seems possible may be impossible. The infinite hotel also introduces the idea of cardinality. A set is countably infinite if its elements can be matched one by one with natural numbers, 1, 2, 3. Even numbers, odd numbers, rational numbers, pairs of natural numbers, they are all countable. The hotel's moves are bijections, perfect pairings of guests with rooms. Once you understand this, what seemed magical becomes mathematics. Philosophically, the infinite hotel raises questions about the universe itself. Could reality be infinite? Could space or time be infinite? If so, the rules of infinity might apply to the cosmos. Thought experiments like this help us explore the edges of logic, reason, and imagination. Students often ask practical questions. Can the infinite hotel exist physically? No. Physics imposes limits of matter, energy, and space. Does infinity have a last number? No. Can the hotel run out of space? Not for countably infinite guests, but uncountably infinite guests cannot fit. These lessons are not abstract. They appear in calculus, topology, physics, cosmology, computer science, and more. Understanding infinity is understanding modern mathematics. Beyond infinity, Hilbert influenced the foundations of mathematics, logic, and physics. He competed with Einstein to finish general relativity, contributed to quantum mechanics formalism, and shaped fields like algebra, geometry, group theory, and mathematical physics. His textbooks educated generations, his problems challenged centuries, and his thinking continues to guide research today. David Hilbert was a testament to intellectual clarity, optimism, and faith in human reasoning. He defended the abstract and counterintuitive when others resisted. He created thought experiments like the Infinite Hotel that transformed how we think about numbers, logic, and possibility. Even today, when teachers explain infinity, they often start with this hotel, a hotel that does not exist, yet changes the way we see reality.